Good afternoon, everyone. Welcome back. Let us continue with the next part of the session. Our next research person is Dr. Tanmoy Halder, Department of Computer Application, Dr. B.C. Roy, Academy of Professional Courses. Dr. Tanmoy Halder, MCA, PhD, is presently holding the post of Associate Professor in the Department of Computer Application at Dr. B.C. Roy Academy of Professional Courses, Durgapur. His area of interest in research is machine learning, remote sensing, and network security. He has 15 years teaching experience in UG and PG courses. He is also the student branch counselor of the Computer Society of India. He will now discuss about introduction to Python and fundamental of data processing. Let us hand over the session to Dr. Halder. Please, sir.
Am I audible?
Yes, sir.
Good afternoon. Good afternoon to all of you. A wonderful session we have observed just before the lunch. Now, after the lunch, actually, first of all, I want to thank all the organizers for giving me the opportunity. Now, my session is actually, as I have thought, this thing will be very interesting. That means lots of my colleagues and friends has been requested that they want to start the machine learning courses. And they are not from computer background actually. So they thought how to start with machine learning. Actually, this is not a big job and not a rocket science. So I thought that let's prepare a session for all those beginners. That means those who are very much interested to start their project in machine learning or want to do any kind of research using machine learning. Before studying the machine learning, obviously they must know the fundamentals of Python. So that's why I have designed the course like this, that first I will give introduction of Python, basics of Python. And after that, I will also give introduction or fundamentals of machine learning. So I'm sharing the presentation. Is it visible? Slide is visible?
Yes, sir.
Okay. Okay, fine. So, as I told, the topic is introduction to Python and fundamentals of machine learning. So, the contents are basic of Python. I have to discuss why Python, how to install, and after that some basic nuts and bolts regarding the language, decision control and statement, string, list, classes, objects. Then I will go for machine learning. And basics of machine learning, there is fundamentals of machine learning. What are the different kinds of machine learning? Supervised, unsupervised, semi-supervised, reinforcement, and what is training data, test data, what are the different kinds of basic areas. So these things I will discuss. So first we need to understand, that means why we have chosen Python. Actually, there are lots of other languages, mainly those who are now watching the, actually joining the session. Lots of people are there, those who are expert in C, maybe expert in C, C++, Java, such kind of languages, because these are present in curriculum. But whenever we think about Python, people think yes, this is very much advanced languages and Python mainly required lots of knowledge. But as per my knowledge, if you have enough knowledge in C programming and basic knowledge of object-oriented programming, then you can easily learn Python. So some points are there that we need to focus here. Why we have chosen Python? First of all, this is open source. Open source means actually no need to purchase it. It is easily available. You can download it and install it. Then high level at the actually high level language. This is a very much high level language. Whenever we are developing any kind of machine learning related project, so this is a high level project development and directly related with the software, very less related with the hardware. So keeping in mind this high level concept, Python concentrate on developing the application or developing the project actually. So from this point of view, Python need to be a well-designed language. That means Python is mainly object-oriented language. We concentrate on object-oriented properties, but Python can also work on the procedure-oriented concept. That means, suppose if you are doing a basic program where all the objects, classes, constructor, destructors, all these things are not required, because these actually number of lines, increase the number of lines. So from that aspect, you can go for the procedure-oriented concept. Simply you can create modules, simply you can create variables, and you can do the programs. But if you choose the object-oriented concept, that means if you are developing a project where you need to define it in class, define it in objects, so you can also go for that. So it works in both the platforms. Now, the second point, that is actually the third point here, Python actually have smaller code. Smaller code means what is the advantage of writing smaller code, you may ask me. Smaller code means Python is developed after developing the C, C++, and Java. So if you are a programmer in Java, you will find for printing something or printing a message, you may use a system.out.println. So you need to understand what is system, what is out, what is println. But Python simply just solve this problem by writing print. You no need to know that what is the class, basic concept, just you need to know. So this is, in this language you have to write less. Another thing is its huge library, sources of library. That's why this is the main reason why you have chosen Python here for designing the machine language, for programming in machine language, machine learning, sorry. You need to you must require lots of modules. For example, I am just giving one example why lots of modules are important here. Suppose I am a computer programmer. I have my degree in computer. So I want to design a module or a code that is already a mathematical module, but I don't have enough knowledge regarding mathematics, regarding that particular basic of mathematics. So ready-made some modules are available, so you can use it, you can understand it, you can use it, you can pass variables through it, and such kind of lots of modules are available. Another example, suppose if I am from another, that is, suppose I am from mechanical background, so I am going to work with Python, and I need a function that is from core computer. So I can go and download that particular computer code as a module and can install here. So that will work. Another thing is lots of libraries. Libraries means actually ready-made libraries are present, that like NumPy, Pandas, SciPy, scikit-learn, Matplotlib. These are required for plotting, for any kind of statistical record. Easily we can create a statistical graph, all these things. So these are the main highlighted issues for choosing Python. Next, I need to concentrate on how to install the Python. Actually, Python, for installing Python, as I told you, this is open source language. So being an open source language, you can directly go to the official website of Python. I have just taken some screenshot. You can go to the Python website, you can easily download. There is an option that you can download the Python, and you have to choose your category, that means what type of operating system you use and which version you want to install here, whether you are downloading for Mac, whether you are downloading for Linux or Windows, and which version of Windows. All these options are there. So you can choose that particular versions and particular operating system, then download it and simple to install. This is the installation process I have shown step by step. As I told you, actually I have designed this course for beginners, mainly those who are going to start their machine learning courses or going to learn Python, and after that they want to start a basic program using machine learning. So that's why I have included all these things. Those who are expert in Python and machine learning, they need to check all these things. Here one thing you must include, that there is a in the screenshot number 2, ideally, actually by default lots of tick are there. That means you must choose this ideally. Actually, ideally is the environment. I'm just showing it what is ideally. In the next slide it is showing. So you must choose this ideally, otherwise you will miss ideally and you cannot start the basics. Fine. Yes, this is the ideal. Ideally means actually this is the basic environment for doing a program. If you install Python in the Python shell, this is the ideally development environment. So here you can simply type programs, and obviously a beautiful GUI. You can run it, you can debug it, you can edit it. And for doing basic programs, just for learning, this ideally is very much important. That one biggest advantage of this ideally. No need to configure your machine. No need to configure your machine. Because we know that for doing Python programming, you must have some higher configuration machines, suppose 4 GB RAM is required or more than that required, all these things. So for running ideally, it can run on just a basic requirement. That means if you have only 2 GB of RAM, it will easily run. Another option is I can download the Anaconda ID. Anaconda ID is actually, this is for developing projects. Those who are going to develop the project, this is actually fit for those people. So this Anaconda ID, why we are choosing Anaconda ID? This is actually a software, and it is actually an environment. It's an environment which provides lots of things, like if any package is not installed, you can search it, you can easily install it. If you want to do any kind of project, if in the project there are different modules, so it will help. So Anaconda also can be downloaded from, I have just given the screenshot from where you can download the Anaconda. And within Anaconda, you will get all these environments. Anaconda distribution is actually, this is the most popular. If most important packages are already installed, and GUI, you will get a GUI. And I have given a screenshot. That means after including Anaconda Navigator, you will get all these options: Anaconda Navigator, Anaconda Prompt, Jupyter Notebook, and Spider. So for programming purpose, you must choose Spider, because the Spider will give you the environment for developing project or program. There, a Jupyter Notebook is also available. You can also do programs there. Anaconda Prompt also will help you, but for beginners, I'll suggest that go for Spider. And in the Spider, when you will open Spider, you will get such kind of window, such a beautiful window. That means this is the best. I suggest if you have high configuration machine, at least 4 GB of RAM, then you can directly go for Anaconda ID, and you can use it. This is the coding editor. Left hand side you can see this is the coding editor. You can write the code here, and in the right hand side bottom, this is the output editor, where you can output window where you can see the output of the program. Now let's come to some fundamentals of Python. While discussing the fundamentals, it came in my mind, actually most of the people attending here, they know C programming languages and Java programming languages. Now I have just tried to highlight the things which are different from C programming languages and Java programming languages. First of all, the thing that is coming in your mind, that is indentation. indentation matters to code the Python programming. Indentation means a space. Actually, Python do not use the concept of curly brackets. We have seen that if you run a for loop, then for loop, you need to use the curly brackets. But in case of Python, no need to use the curly brackets. You can simply use the indentation for programming purpose. Actually, it is a block. Whenever you will give indentation, you will create a block. I have lots of example here. I am coming there step by step. The next slide will show all these things. Another important thing, no need to declare the variable type. This will help you. Variable types mean normally while doing C program, C++ program or Java, I need to declare the type of variable, whether it is integer or whether it is float or whether it is a character. But Python figure out the variable type of its own. That means simply if I write x is equal to 5, then x will be converted into an integer variable. If I write x is equal to 3.7, x will be converted into a float type. If I write x is equal to ABC, then it will be converted into a string. So this is advantages. Next, I have just figured out some of the okay. I've just figured out some of the operators that you can use here. These are the basic operators, and all these are same like C, C++. One thing that you need to focus about, that is logical operators. Logical operators, we may use the and or symbol, but in this case you have to write in words and or and not. Okay. The rest of the operators are almost same. I have tried to highlight the new things in Python, which are actually different from C, C++. Variable declaration. Variable declaration, integers variables we can declare like this, floats like this. For string there is something interesting, very interesting. I will discuss about string later. There are separate section for string. Just I want to inform you now that for Python string, you can use single quotation, double quotation, and even triple quotation. So when to use single quotation, when to use double quotation. Normally we know single quotation is used for character and double quotation is used for string. But in case of Python, you can use single quotation or double quotation. That means here in the example I have shown that double quote ABC is equivalent to single quote ABC. Both are same. It is treated as string. There is a concept of triple quotation also. Normally you don't use the triple quotation. Triple quotation have two purposes. One is for multi-line string. If your string length is too lengthy and if you want to include a multi-line string, then you may use this triple quotation. And for another purpose, suppose if you were using in the last line, if you were using a single quotation and double quotation within the string, that means it is a part of the string itself. These quotations are part of the string itself. Then you can use the triple quote. These things need to be notified because these are very much required actually when you do machine learning programming. These are the basics that you need to concentrate. Otherwise, you will not able to understand the code. White space regarding white space or indentation, I have already discussed. White space means a indentation. This is required for starting a block. No concept of curly brackets. Curly bracket we cannot use here. And the hash symbol we use to block a particular line. If I want that particular line will be not in function, I want to block it, so I can use the hash. Naming rules, same like C, C++, no need to discuss all these things. And there are some reserved words. You cannot use these reserved words for naming purpose. Don't start any kind of naming variable with a digit. I have given all the possibilities of a name. How can I start? I can start with small letter, I can start with capital letter, I can even start with underscore. Even like this underscore, digit, underscore, in this way I can write. Although Python, I mentioned here, although Python have a special meaning of underscore that I cannot discuss here, I'll discuss later. Variable types. I've just mentioned most important variable types used in Python. Integer, float. There are some examples. Integer variable 5. Integer variable 5. Float variable 3.2. String variable put. So no need to mention, as I told you, no need to mention what type of variable I'm using. It will be automatically converted to the particular type. For integer, the variable will be converted into integer. For float, it will be automatically converted into float. And for string, by default, every input is treated as a string. While taking input, I'll show it. Yes, variable can be cast to different types. Casting variable is very easy. For example, if in the first line I have tried to do a float division, so result will be in float. So if I print the result, I will see the result is in float 147.75. Now if I want to display the integer part only, sometimes you require it, so that's why I need to do the typecasting. Normal procedure. So for that, just I need to write integer here. If I want to convert it, CR operand into a rounded here, then I just need to write integer and it will be converted into a integer variable. Yes. In this case, we need to focus for increment and decrement operator. Normally, there is a practice. We used to write x plus plus, x minus minus, pre-increment, post-increment. I think you can remember it, pre-increment, post-increment. There are lots of puzzles in C and C++ and Java using this pre-increment and post-increment. In this case, the x plus plus and x minus minus will not work. Simply, I have to write x plus is equal to 1 or x is equal to x plus 1 or like this. Comparison operators, as simple as I can compare double equals to, greater than equals to, less than equals to, greater than, less than, just like C. Yes. Now the string, Python string is a bit different. First of all, they're telling that string is an immutable data type. Here it is written, immutable data type. What does it mean? Immutable data type, it means from the point of view Python, you cannot change. Once you have created a string, you cannot change the string. So should you not change the string? Yes, obviously you will change the string, but how many times you will change the string? A new string will be created. If you alter the string, it will be created. Okay. So for creating a string, as I told you, I can use a single quote, I can use a double quote, I can use a triple quote. No problem. Here in the example, I have taken one example, hello, hello Leo. I have printed the string, then I have calculated the length, then I have tried to find out the first character of the string, and again in the line number 4, I have tried to find out the last character of the string. Actually, Python works in Python string. Actually, you can read it from forward direction and at the same time also in backward direction. So from forward direction, I have to use the positive indexing, and for backward direction, I have to use the negative indexing. Remember, this indexing I have discussed in the next slide. in detail. So I can also give a positive number, positive integer. At the same time, I can also give a negative integer. Okay. Acha, replace. Replace, this replace function I have used here. If I want to change this string, and if I want to replace it, you can replace it. Okay. Indexing. Normally Python indexing is zero based. Indexing starts from normal indexing starts from 0. As I was discussing about string, if I discuss about list, indexing starts from 0. So the first indexing, if I want to print the first element, then I have to write index 0. It will print the first character. And if I want to print the second character, I have to write 1. So it starts from 0. It proves it starts from 0, just like C and Java. Backward direction. If I want to print from backward direction, as I told you, a Python string could be printed from forward direction, at the same time from backward direction. So if I want to print it from backward direction, I can simply use the negative indexing. Here I have used -1. What does it mean by -1? -1 means the first character from the last. The first character from the last. -2 means the second character from the last. Some more examples I have included here. Look at this example. Dogs are better than cats. Okay, this is a string. Actually, these are not a stride. These are known as stride. So if I write like this, test string 4 then colon, what will happen? Actually, it will start reading from the position number 4. If I have started from 0, D is 0, then 1, O, then 2, G. In this way, it will start from position number 4. And as there is a colon and there is no argument after this colon, it will take the default argument. That means it will continue till the end. That means output will be starting from R better than cats. This is the output. And for the second one, if I miss the first argument, just observe here, I have given a colon first, then I have written the value 4. So in this case, how it will work? It will start reading from where? From actually from the beginning, and it will take only the first 4 characters. Okay. Now come to the next. If I put both the parameters, that means before the colon I have put 5 and after the colon I have put 10. So what will happen? It will start from 0, 1, 2, 3, 4, 5 position, and it will continue till not 10 up to 5, up to 9. You can calculate it from 5 to 9. It will pick from the string. The output will be RB. Okay, it will not consider E. Sometimes we do this mistake. It will not consider E. It will continue till 9. Yes. Next, come to list. Actually, list is most widely used data structure in Python. Wherever you have used array in other languages like C, C++, Java, you have used array for storing more than one data. In this case, list will help you most, because list is very flexible. It is actually, first of all, this is you can alter the elements of list. You can alter the elements of list. So mutable, I have mentioned the term immutable for string. In this case, I will use the term mutable. That means you can change it, and you have to obviously use a square bracket like string. Look at the example. There I have created a list. Actually, no need to mention the keyword list here. If you use the square bracket, automatically it will create a list. Numbers is equal to, with the square bracket, if I write something, then that will be considered as a list. There is a list. But list is not an array, remember. In Python, there are list, there are a tuple, there are a dictionary, there are a set. So all of them have different types of properties, and each of this data structure is different from each other. I have just included list here as it is required most. So if I print the list, the entire list will be printed. If I try to print the type of what type of data structure is this, it will print this is a list. Now, if I want to include something else, one important thing, those who are from C, C++ and Java background, they know that array is homogeneous. Homogeneous means array can only store same type of data. It may be integer or it may be float. I cannot keep integer and float together. But in case of Python list, this is the biggest advantage, that I can keep a string, a integer, a float, a character all together. Okay, so if you look at this example, that I have included arbitrary list is equal to what I have included 1. This is a number, a digit. Then numbers. What is numbers? Numbers is already created list. This list is already created in line number 1. So first a digit, then a list, then a string, and all these will be combined together. Look at the output. All these has been combined together. Yes, it is a, actually if you consider it in terms of array, it is a 2-dimensional array it has created. But purpose of this example is actually I want to show that you can keep the string, digits and float I have not included all together. Fine. These are the advantages. As I told you that Python is the term I used, easy to write, or it is user friendly. These are the things. That's why Python is so much user friendly. Less things to remember. Okay. Some more example using list. I can add some more values. Suppose I have created a list. If I forgot, in this case I want to mention that array is not flexible. Array is not flexible. If I have created an array of size 10, then if I want to include the 11th element, all of us know that it is not possible. The memory error will be given. So Python list is not like that. If you want to include one more element, suppose here 1, 2, 3 is already there. If I want to suppose number 1 is equal to 5, that means I want to alter. Sorry, in this case I have altered it. Altered. I have not increased the list. In the next example, I will do that. If I want to alter, that means instead of 2, I want to include 5. You can just write the index and you can put the value. Here another example where I have included a string and some numbers using insert. There is a function named insert. I have used insert function. If I want to insert this particular string surprise, it will be added in the list at right position. Okay. At what position? 2. I have mentioned here 2. 2 means actually this is the index number 0, 1, 2. At index position 2, the string will be inserted. Something more I have added here for list. Append function. Yes. In the previous slide I was mentioning about if I want to add something, if I want to add. List are flexible. That means no need to think about the memory space. I have created a list 1, 2, 3, variable 1, 2, 3. Then if I want to append one more number, it will be easily added or appended at the end of this list. These things actually help very much whenever you work with data. When you work with work for data science, for handling the data, when you keep lots of data in list, so this is very much beneficial while programming. But if you follow array, at that time this become very rigid. As we can append, we can also remove. We can also remove numbers. I have removed a number. As I have added, I have removed a number in the second example. You can see that after removing the number will be totally removed. I no need to think about the memory. Normally we think if I remove an element from the array, the position will be vacant, and whether should I override, or whether it will be permanently deleted from primary memory, or whether it will be create any kind of a garbage value. So no need to think all about that. As I told you, this is a high level language. Actually don't get bothered about all these things. Yes, this example I have tried to show something in very detail how the list works. I have chosen some example. The left hand side are easy examples. The indexing of list. This is a list where 0, 1, 2, 3, 4, 5, all the elements are there. I tried to just look at the right hand side column. If I start from indexing 0, and if I want to continue till end, then this will be the same syntax. Starting position 0, ending position by default ending position, that means till end. All the elements will be printed. In the second example, I have used no argument, no starting argument, no ending argument. So easily we can guess that the starting argument will be also default and the ending argument will be also default. All the values will be printed starting from 0 to till end. In the third example, I have given value for both the arguments. What will happen? For both the arguments, it will start from indexing 0, 1, 2, 0, 1, 2, and it will continue till 0, 1, 2, 3, 4. Okay, that means not up to 4, because 0, 1, 2, 3. That means up to 3, 0, 1, 2, 3. Remember, it will not print 4. It will print till 3. That means in this case, actually, if you want to remember, you will always remember that it is working less than, not less than equals to. Less than. Another example in the next one, 1, 2, 3. You can check it. And the last one, I have kept blank the first argument. That is the default argument starting from 0 and continuing till position 3, 0, 1, 2, 3. Okay. Now, this is the diagram where the entire thing that I have discussed till now regarding list and regarding string, the entire picture will be clear if you just remember this particular diagram at the top. This is the indexing, how it is followed in Python. This is the list. The numbers are there. If you use positive indexing, then it will start from 0, just like array 0, 1, 2, 3, 4, 5. But if you use negative indexing, always don't do mistake that it will never start from 0. It will start from -1 from right side. -1, -2, -3, -4, -5, -6. So these two indexing concepts are different. Okay, I have chosen some example from this diagram. Some examples are there. Negative indexing examples. 1, 2, 3, 4, 5. This is the list. If I write print list -1 only, then the last element will be printed, 5 will be printed. If I print -3, then colon, and the last argument is blank. That means it will print 3, 4, and 5. 3, 4, and 5 means it will take last 3 arguments. That means it will pick from the last. It is not considering from first. As I have given a negative indexing, it is considering from last. Okay. So it is considering from last and continuing till the end. Next one, the first argument is blank and then -1. That means it will start from the beginning and it will continue till the second last element, -1. And the last one, -3, -1. Starting from the index -3 and continuing less than, not less than equals to, less than -1. That's why 3 and 4 has been printed, not 3, 4, 5. Okay. Okay, tuples. Actually, tuple is another data structure. In this data structure, there is a difference between list and tuple. Tuples are immutable. Their working procedure is same like list. But when we prefer tuple when we don't want to alter the data we created or the numbers we have entered, as this is immutable. Remember, Python list is mutable. That means we can alter, change. So those functions for altering the list, those functions will not work here for tuple. Okay. And how to define a tuple? For defining a tuple, you have to use the first brackets. The parenthesis. Parenthesis is the first bracket you have to use. Python will automatically decide that whether you are defining a tuple or a list depending on the brackets. Now let's discuss something about loop. Actually, without looping I cannot program. So looping in for loop. For this structure is also different from C, C++. In this case, mainly we use two things, either is in or another format. In this slide, I have not mentioned that format. In the next slide, it is range function. I'm talking about range function. So simply you just create a list. There is a list of dog, cat, shark, falcon, all these things. And for I in spaces, just enter. These things are very much useful while working with data. If you have kept some data in this list, then if you want to print it, if you want to check it, just simple run a for loop and give name of the list. Okay, this is the output. This is the another example I have shown that where you can calculate the sum of these numbers using for loop. Yes, remember I talked about indent or spaces. So look at this example, this for loop. Here what I'm doing, I'm not using the concept of curly bracket. What I'm using a colon, and I am following the indent. That means I'm giving a space from left hand side. So this space will think, the Python interpreter will think that yes, this line total is equal to total plus value. This line is within the for loop. This is within the for loop. And if I change the indent, then it will think, yes, I am out of the for loop. This print total, this line is out of this for loop. How? Because this is not following the indent. It is out of this indent. Indent actually, most of the errors I have seen while working in Python, those arises due to the misuse of indent. The range function. This is the range function is used in for loop. This will automatically create range. Just look how beautifully this is designed. For I in range 5, no need to write anything else. For I in range 5, if I want to print the numbers, just print I, which will automatically start it from 0 and automatically it will create the range of 5 values 0, 1, 2, 3, 4. The next example, I have used two arguments in for loop. I in range 3, 6. So obviously, all of you understand that the A3 is the starting position and 6 is the ending position. That means it will start from 3, 4, 5. Okay. Next, the third argument. For range function, actually, I can give 3 arguments. So if I miss any argument, that means if I give only one argument, this will think that starting is default, increment or decrement is by default, that is by 1, and this is the ending condition where the loop will stop. If you give 2 arguments, then it will think you have given the starting condition and the ending condition, and the increment is by default 1. And if you give 3 arguments, then first one will be the starting, middle one will be the stopping, and the last one will be the increment or decrement. That means the numbers will be incremented by 2. This is the difference with C, C++, and Java. Append function. Append actually, this append function is maximum time combined with the list for inserting new value. If I want to create a list, this particular program is important because if I want to create a list, I want to input a number, and runtime the list will be created. Whatever the number I will give input, that will be included in the list. So for that I can use this append function. I will run a I will run a for loop, and I will use a append function, append I. Append I means here value of I is 1, 2, 3, 4. Instead of I, you can use variables that you can take as input, and that will be appended in the list. Automatically the list will be created. User defined list. Runtime you can enter value. While loop. This is quite similar with C, C++. There is nothing so new here. Simple, just I have to give the while I less than 3, the logic condition, stopping condition, and same following the intent. Here also you cannot use the concept of curly brackets. You have to use the concept of indent, print, and this increment. These 2 lines are under this while loop. One example of nested loop, I have included it to show the concept of indent. As I told you, maximum error comes from indent. So for x in range, this is the first for loop, then there is another for loop within it. This is the nested for loop. Just look at the indent I have followed. First I have given one indent, then again for the second for loop I have used another indent. That means the print statement is under the second for loop for y. Then function is required because for any kind of coding, whether it is small or big, if we use a function, the program will be structured. This is not necessary always you have to use the object-oriented concept of Python. If you work in Java or C++, for every program you have to start with object-oriented concepts. You have to create a class, you have to create objects. In case of Python, I have seen that while as a beginner, whenever you are starting, so you can create small modules or small functions, and you can exchange values between functions. if you look at the example of this function, this def keyword is used for each and every function, followed by the function name, and there the arguments, and same indent will be followed. No concept of again curly brackets, indent you have to follow. Return in case of function is by default there is a return which returns none. If you write the return statement, then it will return the prescribed or desired value. Calling a function, you have to call this function from outside the function, and you have to follow this indent. Actually, x is equal to 5, y is equal to 4. Whenever I am writing here, if you follow the program, x is equal to 5, y is equal to 4, I have followed the indent, the same indent that I have followed for writing definition, def. That means these are out of this function. Next, I have tried to give a very brief idea regarding classes and objects in Python. As this is an object-oriented programming, as I mentioned, that you may choose the procedure-oriented concept, simply function-driven program, or if you choose, you may go for the object-oriented concept of Python. So if you choose the object-oriented concepts, creating a class, this is not a big job. Creating a class, very simple. Just give the use the keyword class, then the class name, and declare the variables. And for creating objects, simply here p1 is the object name is equal to class name. Object will be created. As we know that calling any kind of variable or any kind of data members of a class, we need to use the object name dot class name. The same syntax is followed here. Object name p1 and the variable name x. Some more examples there. Okay. Fine. The init function, actually Python use this init function. You may call this is one kind of constructor. Those who are familiar with the concept of constructor in C++, the constructor actually when you declare object, it automatically it is called. So in case of Python, the init function actually works like a constructor. Some examples are there. I have used init. For example, there is a class person, there is a class, then there is a function, and name of the function I have used init, predefined. There is an argument, self argument is mandatory here. If you have to use self argument, it works like if you remember this keyword in Java, which refer the particular object for which it is called. So the self argument actually do the same here. And if you observe the program, if you see that when I have called p1 is equal to person, I have passed only two arguments. One is John, that is a string argument, and second one is an integer argument. So as per the norms of C, C++ and Java, while declaring the function, I need to declare only two variables. One is name and age. But I have used one extra variable here, that is self. Okay, because this is, as I told you, sometimes we found that this argument in Java, it will work like that. If you want to initialize the class variables, you have to use this self.name is equal to name, self.age is equal to age. Then this variable will be initialized. So if you are passing one argument, then you have to declare here two arguments. One is self and that argument. If you are passing two arguments, you have to declare two arguments and the first argument will be self. If you are declaring no argument, then you have to only declare self here. Okay. This example I have included just to show that this self argument, the name self you may change. You can give any kind of other name, user defined name. Just here in this example, I have removed the name self. I have used any kind of user defined name. My silly object. This is the name of this argument. So it will work. Whatever the name you will give here. In this function ABC. As I told you in the previous slide, if there is no argument, then there will be a self argument. So in this function, my function, I have used only one argument, and that is ABC. So what does it mean? This is actually replacing self. And look how it proves. When I'm calling it, when I'm calling p1.my function, there is no argument, but there is an argument. There is an argument, but in this case, there is no argument. That means self will be the default argument that you have to follow. So I have just renamed the self argument. I'm not discussing too much regarding this object oriented because also I have to discuss the concept of machine learning, fundamentals of machine learning. One thing I must include, because without this, this presentation would not be complete. This module, as I told you, Python Python get the biggest advantage from its predefined modules and some other third-party designed modules. So how to include those modules? How to include those? Simply use the import function. Import keyword. If I write import math is a predefined module, and I can use the pi is a math.py. Pi is a predefined variable which will get the value of pi. So if I print it, it will be printed, but before that I have to import the math module. Two examples I have shown here. One is import math. That means the entire math module will be imported. In the second example, I have shown that if you want to import only this pi, only want to use this pi, so you can also write from math import pi. Another one, I have import random, this random module, and I have generated random number, some random number, and int is, this is a function already present here, and I want to generate a random number between 1 and 10. This is the range. So for that I have imported this random function. Okay. Allies. Sometimes we want to give some nickname of this module. Actually, why this concept has been taken, because there are some name of some modules which is very tough to remember or tough to write again and again within the program. So that's why we try to give some nickname. Just like us, we have a nickname that our near people use this nickname. So in this case, I have just given a nickname. Import math as aim. So math will be nicknamed as name, sorry. And anywhere in the program, if you want to use this math, then you may use this name m. M will be the nickname of this allies or nickname of this particular module. So already I have tried to give a brief regarding this language. My next part will be start with machine learning. Already I have taken almost 1 hour. Fine. So this basic practice, actually, if you know all these things, you may start machine learning. Basic program using machine learning, that is gathering data, all these things. I'm just giving you what you have to do. So machine learning, this is highly related with Python, and I have already told you why Python is so essential for machine learning because machine learning includes lots of data gathering, collecting of data, analysis of data. So for that, Python is most suitable because Python have a rich library resource where you can download the codes, where you can write the codes, and Python is easy to manage. Most of the machine learning programs start from this, actually designed using this Python. So regarding this, before I start the introduction of machine learning, actually I want to tell you, nowadays this AI, artificial intelligence, is everywhere. Wherever you go, everywhere you find this artificial intelligence. Everywhere we are using AI, everywhere, even in your mobile phone, even in your computer, everywhere you are using this machine learning or artificial intelligence. So what this thing is, so if you just think of machine learning means, this is just like a machine is like a child, children. I was listening the first session, Subhamay sir. So he has also given a beautiful introduction of what is data science and what is machine learning. If you have already listened, so already my introduction is completed. So machine learning means we're trying to educate the machine with valuable inputs. Educate means so that it can behave accordingly in good situation, in bad situation. So how to do that? Actually, there is a difference between these two kinds of learning. A traditional learning that we used to follow in our daily life and the machine learning. So what is the basic difference? In case of traditional learning, the input data, I have to provide the input data. Along with that, I have to also provide the operations, how to process the input data. And then the outcome will come. That means if you are giving you two variables A and B, then I have to tell you how I will get C. That means if the value of A and B is 2 and 3, then how to get 5, that I have to teach you first, traditional learning. But if you just convert this example in terms of machine, then what will happen? I will give you the input to variables A and B, and I will give you the values 2 and 3, and I will give you the desired output. I want 5. Then how you will do that? You have to do. That means the machine will do, and machine will automatically calculate whether the machine have to do subtraction or multiplication or addition, whatever, to get the result. This is the difference between traditional learning and machine learning. Now, applications, where it is applied. No need to tell all these things because everywhere, whenever we are opening our mobile phone, we can see lots of messages are coming, even from lots of shopping website, lots of promotional videos are coming, promotional advertisements are coming. So they are tracking us from very morning. Whenever you are opening the mobile, whenever you are showing your interest on the mobile, what type of things you are observing or checking, or sites you are opening. So they are observing, and based on that, everywhere they have applied this artificial intelligence and machine learning. So I've just given, I'm just mentioning some names: stock market trading, online fraud detection, virtual personal assistants, email spam, self-driving cars, traffic protection, speech recognition, image recognition, lots of applications are there. This slide is very important to understand the machine learning, or how machine learning works actually. So this slide actually tells us about the step-by-step procedure, what I have to do. If I want to start a program using machine learning, very simply you can start with a program. When I started machine learning at the beginning, just I have downloaded one data. First step is gathering data. Gathering data means where you will get the data. The normal data that we get, that may not work, because collecting a real life data is very tough. So for practice purpose, from Kaggle you can download data. There is a website where you can get some machine learning data set. This is known as data set. So data set you can easily download it for practice purpose. So gathering data, then data preparation. All of you know the data is not ready for working. There are lots of garbage, that means some values, some null values are there, some values are there which is not relevant. So you have to prepare the data, whether it is relevant or not. Data wrangling, you may change the data. Data wrangling, you may change the data, you may alter the data. That means you have to process the data ultimately. Then analyzing the data. Analyze the data, then train the model. That means I am feeding the data to a model. Model means there is nothing but a software. I'm giving this data, and according to the data, my model or my program will work. That means I'm training that module. Now, after training, I have to also test the module. Then, after giving training, I will test whether my module is working or not properly. How much accuracy it is giving me? 80%, 90%, 95%, 70%. Then deployment, that is you apply it. So these are the basic steps required. First you have to gather the data, then you have to filter the data, filter or rank the data, then analyze the data, then train the model, after that test the model, and then deploy it or use it. So for doing this, actually there are three types of process. Machine learning. Normally when we talk about machine learning, these terms are very usual now: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So I'm discussing one by one. First I'm starting with supervised learning. Supervised learning, actually majority of people actually choose for the supervised learning. Supervised learning means a supervision is already present. For example, going to the next slide, actually, this is a supervised learning. Diagram is shown here. For example, this is the data set. The first set of fruits, vegetables. The first set of vegetables, there are some tomatoes, some carrots, some bell peppers. So these are the set data set that I have collected, image data set. Now I have already informed the machine about the data set. This is tomato, this is carrot, this is bell pepper. So according to that, how it will be identified? Because there are individual features. A tomato has a particular shape, tomato has a particular color, tomato has a particular texture. The carrot also have all these same properties, but they are different from tomato. And obviously a bell pepper is different from tomato. So I will give different kinds of images. Actually here all the images are same in this image, this data set, but what happens, we provide different kinds of images of capsicum or bell pepper or carrot or tomato, and I will label those data at the beginning. Then from that the model will train itself. That is the training process. The model will train itself. If we found this property, if the color is red, okay, first choose this is a tomato. Then again if found another one is coming, another feature, that is, yes, this color is also red. A carrot may be also red, a bell pepper may also be red. Okay, so at that time it will be confused whether it is a tomato, whether it is a carrot, whether it is a bell pepper, because some bell pepper may be red, some tomato, all tomatoes are red, and some carrots are also near about red. Then it will go for the second feature. That means what is the shape? It will judge the shape. If that is also not satisfied, it may go for the texture or some other properties or some other features. So depending on that, it will come to the decision that yes, my prediction is okay. Now for prediction is okay or not, for that again I have to test there is a set of test data. In the set of test data, again I have to check whether this prediction is correct or not, and if it is correct, then I may apply it in real life. So that I was telling about in the previous slide. Supervised learning input data is required in terms of feature data. Feature data, accordingly, outputs are required in order to specify the target value. Okay. Now, for supervised learning, there are two types of supervised learning. One is classification. The example that I have already given you, that is one kind of classification problem. Classification means I can categorize. Nowadays, you will find that the Google Lens, if you take a picture of anything at your home, picture of any kind of image, so Google Lens will identify. So that is a very high-end programming. I'm just taking it as an example. So this is one kind of classification it is using, making it different from other images and can identify it. I can identify cats and dog. I can identify flower species. Next one is regression. Regression is supervised learning, but it works in some other ways. It is used for some prediction. For example, stock market prediction. Price of a house. I'm predicting the price of a house. How old is this? How big is this? Where it is located? All these things. All this raw data I will provide, and from that it will give me a prediction. Yes, this will be the approximate cost of this particular house. This type of example of regression model. Here we are not classifying. A classification means whenever we are differentiating between two types of categories. More examples are there. This is one kind of architecture of supervised learning where the level data set is there. First we have to do, look here, X and Y. What is this X and Y? Training data and test data. Suppose I have a data set of 3000 data. For example, I have downloaded a data set where there are 3000 data. So what I have to do, I will not use all those data to train my model. I will first break it into training data and test data. I have to keep some data separate. This ratio may be 70:30, this ratio may be 80:20. Normally, these are the well-known ratio we use in machine learning. So we have to divide this data into X and Y, that means training data and test data. This training data will be used for training the model. To learn the model will learn from the training data. And after that, we will test using that test data that we already kept separately for testing purpose. And we will test the model using the test data whether it is working properly or not. This example I have taken to show you the difference between classification and regression that I told you already in this slide. Yes. In the first slide, there are classification and regression. Two types of supervised learning are there. So classification and regression. Classification means actually if there are some red dots and there are some green dots. Already have given you example. So this classification will create a distinction between this red dot and this green dot automatically. That means such a line would be drawn that it will be differentiate the green and the red. I'm classifying the data, but regression means it will try to draw a line. Suppose I want to choose the best line. Just remember my example where I have given I want to predict the price of a house. I want to predict the price of the stock. I want to predict such kind of numbers. So what will be the best prediction? That line will be chosen. So this is regression. Another one, classification versus regression. An easy example I have chosen. This is a table, a very small table. So roll number and section are given. According to the roll number, a machine is already dividing the section. So it has taken from roll number 1 to 50, maybe from section A. Above 50 it will be B, and above 100 it will be C. So this is an example, very easy example. This is classification example, and regression means actually I'm calculating some price. The item of price 1, item of price 2, a total price. So this is regression. Okay, now the next one is unsupervised learning. In case of unsupervised learning, actually no such label data is present. Label data is not present. That means I will not inform the machine that this is an apple and this is an orange or this is a carrot. I will not inform. If I go to the diagram, here we can see for unsupervised machine learning, this is the input raw data, unlabeled data. I have mentioned nowhere that these are the oranges and these are the apples. Now, what the machine is doing, it is understanding the structure, the properties. The properties, it is understanding what are the properties, and obviously there are some differences, and from those differences it is categorizing which are apple and which are oranges. So this is unsupervised data. For unsupervised data, we have to use unlabeled data. Remember, for supervised learning, we have used labeled data, but in this case, I am using unlabeled data. This is the architecture of this unsupervised learning. Everything is same, but I have used unlabeled data set, but data set is not labeled. Because in real life, it is not always possible that you will get the labeled data. Unsupervised learning. For unsupervised learning, I have given one example. There are two types of unsupervised learning. One is association and clustering. This example, just look at this example. You will easily understand what is association. For example, if you are going to any kind of shopping website, Amazon or Flipkart, wherever you are going, suppose you have seen this situation. Suppose you have purchased a bat, a cricket bat. Automatically, a suggestion of buying a cricket ball will come. That means they are associating. If you were buying X, then obviously you will buy Y. This is association unsupervised learning. And clustering of unsupervised data is, again, I am taking one example of one shopping website, because they are highly using all these kind of AI related concepts. Each and every day we are being trapped. So from the type of category, they can identify whether you are a boy or you are a girl based on the things you are buying, and based on that they are preparing their data or identifying you. That means this is clustering. Remember, you can create the difference. Don't actually confuse with the supervised and unsupervised, because in case of supervised, I have already given that this is a boy and that is a girl. But in this case, I am not giving you the data that this is a boy and this is a girl. It is being derived, that is from your purchase category, what type of things you are purchasing. From unlabeled data, they are categorizing whether you are a boy or you are a girl. Okay. Semi-supervised, a real situation. When happens? Whenever a huge data set is available, but all the data are not labeled. Some data are labeled and some data are not labeled. Machine will learn from the labeled data, and after that they will automatically identify the unlabeled data. Example, semi-supervised learning. Input data, this is the input data, and some are labeled. This is orange, this is orange is labeled. I have given input of orange, okay, and this is banana, fine, but apple is unlabeled. How the machine will identify? Obviously, some properties are there, some features are there, features of orange it will get, features of banana it will get, and from that it will identify which is not falling under all these features. Then obviously this is another type of fruit, and that may be apple. So this is semi-supervised learning. Another beautiful example of semi-supervised learning. This example is so realistic. This is a data set. Actually, in the first data set, I can see the image of a train, a tram, image of a tram. So the machine is actually understanding this image from the data set, that this image is 270-degree rotated. Actually, this image is not straight. How it understood? Because it has observed different data here from the data set, and it has observed this is an image of a tram and it is 270-degree rotated. So this image is 270-degree rotated. Now from the second data set, it can see there is a hat. There is a hat. So it can identify the hat from another data set. Yes, this is the hat. It can identify. Now in the third image, if I give the third image, this image is a girl is wearing a hat, but the image is rotated. So from these two information, the machine can collect this information. Thus, there is a 270-degree rotated hat here. Okay. So this is another example. Don't have enough time now. Reinforcement learning. Reinforcement learning, actually, this is another type of learning. This is mainly used for gaming purpose. Reinforcement means the machine will act according to the situation. Just look at this example. An example is taken here. Suppose this dog is an agent, okay, and you are the environment. The dog action is dog is barking at you and coming to you. Now, what is your reward? You may entertain the dog by giving some food. You may want to give something else. That means you want to avoid the dog. You are threatening the dog. Okay. So according to that, the dog will behave. Same thing for reinforcement learning is, if you are giving some actually agent, that means one kind of input. So how it will work? It depends on the situation, on the present scenario. One more example you can take. Suppose if you were online chess. So whenever it's your turn, and based on your turn, the opponent will give his or her turn, and based on that your next turn will be. So that means depending on the situation, you have to choose the term. So this is reinforcement learning. One more example of reinforcement learning I have tried to include it here. Raw input data. There are different kinds of shapes, and this is the agent. That agent is actually working on that, and they are trying to segment, and they have already segmented the data based on their shapes, based on their color or whatever. So mainly supervised learning is widely used, semi-supervised, unsupervised. These are used depending on the situation, and reinforcement learning obviously very widely used now. Okay, reactive agents, proactive agents. Actually, there are two types of agents, as I told you. Reactive agents are response immediately they respond, and proactive agents don't respond immediately. They actually gather information. And they react later. They take initiative and plan ahead to achieve the goal. That means this may you think reactive agents. Suppose according to that, if I take this example, suppose the dog why the dog was barking? The dog was coming to you because there is some food behind you. So if you were threatening the dog, if it is a reactive agent, then it will immediately go away, or it will try to attack you. If it is a proactive agent, the dog will plan. Yes, I have to wait. When the environment will be in favor of me, I will do my job. That means it is planning for the goal. So this is reactive agent and proactive agent. Environment, obviously you understood what is environment. That means punishing, rewarding, all these are environment. The last one I must mention what is training data and test data. Already I have mentioned what is training data and test data. So no need to mention it now. Earlier I have mentioned it. Splitting that training and test data is very important. A proper ratio. Two types of errors are there. Actually, running out of time. So there are two types of error: bias error and variance error. So this finds a similarity. Bias error mainly the discrepancies that we found while prediction. So for low bias there are fewer assumptions, and for high bias, a model with high bias can make more assumptions. Okay, and variance means amount, that is that amount by which the performance is predictive or not. So these are the mainly two types of error that we need to manage after doing the predicting the model. So as if the error is less, then the model is actually more acceptable. And some libraries I have included, library packages that we must need. Already I have discussed the basics of Python, and these libraries, these are the library packages that you must include. NumPy, pandas for analysis. This is a data analysis library. Matplotlib for plotting different graphs. The plotting that I have shown you for regression, for classification, you can do easily using this Matplotlib. Scikit-learn you may use for data analysis. Shivon, another one. So lots of packages are there. Actually, in the newer version of Python 3, nowadays Python 3 works. So for Python 3, installing Python 3, I forgot one thing, that you must use Windows 10 or higher. It will not work in Windows 7. So in Python 3 you will get all these libraries already. These are involved. If it is not involved, I will suggest you to better use this Anaconda. Anaconda will give you will allow you to easily install all these libraries and packages. So last one, another example. I've tried to took. First you have to for the image classification, load the image dataset, pre-process the image dataset, encoding target value, divide the data into training and test, feed the pre-processing image into the model, apply the test image and make assumptions, and compare the model performance. These are the steps that you need for basic machine learning process. Okay, hope all of will be benefited from this session. I have tried to explain very brief. Actually, this session is the topic that I have chosen is very lengthy. It is not possible to explain machine learning at the same time Python programming language within this short period of time. I have just tried to brief those. You may ask any question. Feel free to ask any question.
Excuse me, sir. Thank you, sir, for your wonderful session.
Hello.
Hello, yes, I'm listening.
Sir, I have one questions. Can you clarify one thing that how the memory will be allocated in Python? Suppose I declared any variable in Python. So how the memory will be allocated behind the scene? How the memory will be allocated for those variables?
Uh, your question is that means how the memory will be allocated.
Yeah. Suppose I declare something. I declared some variables. So how the memory will be allocated?
Actually, as I told, Python memory allocated is it depends on the variable. That means for C and C++, like C++, we need to declare the variables. So the memory amount actually pre-allocated. If I declare integer variable, then that amount of memory will be already engaged for that particular variable, and I cannot change it. But in case of Python, it is automatically converted. For example, suppose if you are taking x is equal to 5, so it will take that this is an integer variable, that integer variable you are assigning, sorry, integer value you are assigning to the variable. So automatically that will be converted into integer, and that amount space will be taken in memory. If you were taking a float variable in the same variable x, so x will be automatically converted into a float, and that amount of memory will be allocated. So in Python, this advantage we get that no need to think about previously or static. In the static way, you don't have to think about the memory allocation.
Okay, sir. Okay. Thank you.
Welcome.
Thank you, sir, for the wonderful session. If anyone has any question, then can feel free to ask. If anyone have any question. Thank you, sir. So we forward our program.
Thank you very much. I want to thank the entire team for giving me the opportunity. Thank you very much.
Okay, welcome, sir. Now I am requesting our program convener to conclude today's session. Sir, please.
Thank you all participants. That's all for day one. We will join tomorrow's session at about 10:30 a.m. Okay. Have a nice day.
Okay. Thank you, sir.
সেখান থেকে প্রভাব স্ট্রেস তো ফার্স্ট প্রসেসটা আছে কি করে সেটা তো উল্লেখ হবে